I'm back. Now we're going to start with 2.2, and on this occasion we'll actually start doing graphs, and we'll try to use graphical representations and try to solve problems using that. Okay, so first of all, if you have a graph, can you just eyeball it and say, yeah, that's a graph of a function, or no, that's not a graph of a function, actually that's not a function? Okay, so can you say that? Can you just eyeball it and decide that this graph is of a function, or this is not of a function? That means you need to decide by just eyeballing that whether or not your graph is for a function or not, the graph of a function or not. Okay, so if you remember, in my previous video, I said if you have a graph like this, okay, whatever your curve is, let's say your curve looks like this, okay, I said if you just draw parallel line to the y-axis like this, wherever you want, doesn't matter, as long as it's parallel to the y-axis. If you draw a line like that, if it intersects your curve, which is in this occasion this white semicircle, it looks like a semicircle anyway. So if the parallel line to the y-axis intersects your curve into just only one point, like this one, then we say that that is a function. Okay, and vice versa, of course. That means if it intersects, if the red line, that means the line parallel to the y-axis, intersects your curve in more than one points, then we say that this guy is not a function. Okay, let's see one example of that as well. Okay, let me draw new line of axis. Let's say our curve looks like this. Okay, now again, as I said, the basic idea is you need to draw a parallel line. You need to draw a line parallel to the y-axis. If I do that, that's my y-axis. If I draw a parallel line to that, as you can see, that parallel line has actually intersected my curve into 2 points. So that means we'll say that this is not a function. Okay, so even without drawing on paper or on your iPad, you can actually imagine the graph and see if you draw a parallel line to the y-axis, in how many points your parallel line intersect with the curve, with the given curve. And that way you can actually decide whether or not that's a function. Okay, let's move on. Now, if I say from the graph, you need to find different values. So I'll start with this. Let me draw a new graph. I'll start from here. That's a sine curve. And if you're wondering what's the sine curve, you don't need to die wondering. That's not a part of our topic. We want to see what happens if we want to get different values from a graph. Okay, so this guy is 0, 0. That point is pi over 4, comma 2. Oops, that doesn't look good. So I'll use this. So that's our first point. Okay. That guy is pi over 2 and 0. So let me write it here. Okay. The line or the extreme point below the curve here we have 3 pi over 4. Let me write it here. 3 pi over 4 and -2. Okay. The other point on the x-axis is pi and 0. So that's our pi and 0. At the top, we have another extreme point. That's 5 pi over 4, comma 2. These informations are given, by the way, so don't worry about it. I'm just first setting up the question, and then we'll continue from there, okay? And the next one, that means this is 3 pi over 2 and 0. So 3 pi over 2, 0. Okay, okay, so that's our graph. Now from this, if I say, what are the values of the function, let's say this. What's the value of f of 0? That means, what's the value when x is 0? Can you see that? Here, let me rewrite it. Here, at this point, x is 0. And I can see, without even going for any explicit calculation, I can see that the corresponding value is 0 as well. So I can clearly write that, hey, the functional value at 0 is also 0. Now, what if I say, find the value at, let's say, pi over 4? That means the functional value at pi over 4. We need to find the point where x is actually pi over 4, because always remember, we do get values like this, right? Where x is the independent variable and y is dependent on x. So we're looking for the value of x. So here x is pi over 4, and I can eyeball pi over 4 here, which is the value of x. And of course, I can see the corresponding value is 2. So I can clearly, as I said, without doing an explicit calculation, I can straight away write a 2 here. Can you see what I'm doing here? If you have any question, don't hesitate to temper me, okay? You can always send me emails, and maybe you can talk about this tomorrow as well, if you want, okay? Okay, now, let's just see one more example like this. Then we'll continue to, or rather proceed to the next one. So let's say 3 pi over 4. 3 pi over 4. What's the value of that? And I can see a 3 pi over 4 here. That's the value of x, of course. And the corresponding value is -2. So straight away, I can write a -2, right? So that's quite easy. Now, let's move to the next one. If I say, find the domain of the graph of the function, okay? Now, if I go for the domain, if you remember, domain is the value of x, okay? So, let us see what are the values of x we have in our hands. Let me use a different color, a 0, pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, 3 pi over 2. All the values in these coordinates has 2 different points, or rather 2 different values, right? All the points on this graph has 2 different coordinates. Of course, the first one always comes from x, second one always comes from y. So all the first positioned value is actually our domain. Can you see that? If I say list all the domain, then you can do that. But remember, that's crucial here. This graph is a continuous one, right? So apart from these underlined values, we also have other values everywhere in the graph, right? We have values everywhere in the graph. So we want to know how to generalize or how to write that using mathematical notation. So that's quite easy. We need to see the two ending points. That means we need to find the boundary points, the point where it started, the point where it will stop. So as far as I can see, let me use a different color. Let me use this. Okay. So this graph has started at 0 right here, and it has ended here, right? And this point, okay, I didn't write that point. So let me write it for you. That point is actually 7 pi over 4, 7 pi over 4, and negative 2. So you can see the graph actually ends there. We started from here and we're ending it here. So that means all the values from 0 to 7 pi over 4 is a part of our domain. In other words, we can write it this way, right? X is from right from 0, right from this one, we go all the way up to 7 pi over 4. So all the values of X within this region is a part of our domain. So we can write it this way, or if you are asked to write using the interval sign, you can use this. We'll start from 0 and we'll end at 7 pi over 4. Of course, use the closed notation because 0 and 7 pi over 4 is included. So that's how you can write either this or that. Okay, that's the domain. Now, what could be the range? This could be tricky. Okay, but you can also eyeball that. You don't need to go for any explicit calculation. So if I say what's the domain, let me write it here. Oh, that's your domain. That's your range, and that's values, functional values. Okay. Okay. Now, if we just eyeball it, if you go to the topmost point at this graph, like this one, here or here, you can see the value is 2. We don't have any value beyond that, right? And if you go to the lowest points, like this and this, you can see the functional value, the value of y, which is of course range on this occasion, hasn't gone beyond this negative 2. So you can clearly imagine whatever your value of x is, we are getting a value which is in between these 2 and negative 2, right? So we can write straight away that our range is from negative 2 to 2. Can you see that? Because whatever you take, your value of y hasn't gone past these 2, hasn't gone beyond this negative or below this negative 2 either. As you can see, negative 2 and positive 2. So your values should lie between these two values. You can clearly say our range is there, or using set notation, we can write it's from negative 2 to 2, right? We write range using y, we write domain using x, okay? Okay, now, next we want to see the intercepts. That means where the graph has intersected the axis. here we can see it hasn't really intersected the y-axis anywhere apart from this point 0, 0. But we do have a couple of points on the x-axis where this graph has gone past, like this one. At this point, this curve has actually intersected this x-axis. Can you see that? At this point as well, this curve has actually intersected the x-axis. Let me use a different color. There you go. Okay. Same here as well. The point at which our curve intersects the axis, right? We can actually see 3 different points like that. So our intercepts are, if we just use this color, this is an intercept, this is an intercept as well, and this is an intercept as well, right? So we can clearly write pi over 2, 0, 3 pi over, or no, I think it should be pi, only pi, right? Yeah, it's pi over pi and 0. And the last one is 3 pi over 2 over 0, and 0, rather, sorry. 3 pi over 2 and 0. So these are our intercepts, okay? And finally, we want to see how many times does the line y equals -1 intersect the graph, okay? Now, how can we do that? So first of all, we need to go back to the graph. It looks messy, so let me redraw the graph for your convenience. Oops, I think I should start from, yeah, start from left, because it will allow me to have more space. And this is -2, okay? And this is +2, as you have seen. That graph hasn't really gone past these 2 points, okay? And our question said, let me go back to the question again. Okay, how many times does the line y equals -1 intersect the graph? So first of all, we want to draw a line at y equals -1. So that's my y equals -1, okay? If we draw a line here, so the question asked how many times, that means in how many places this red line, this is actually parallel, I think I should redraw it. This is actually parallel to the x-axis, okay? Because y equals -1 means whatever you take x, your corresponding value will be -1. So this y equals -1 is parallel to the x-axis, and it goes through this -1 point on either side, okay? So the question said how many times this has intersected our curve. So you can actually eyeball it. It has intersected our curve here, here as well, and here. So the answer is 3 times. Okay. Okay, next. Our next question is, for what values of x does f of x equals -2? That means our questionnaire said, find the values of x for which we will get -2 as the functional value or the corresponding value of y. We can actually go back to our previous graph. As far as our graphing is concerned, you can see for 3 pi over 2, we're getting a -2. For 7 pi over 2, we're getting another -2, right? We can actually eyeball it. So we'll say the values of x would be 3 pi over, oh, let me see again. 3 pi over 4 and 7 pi over 4. Okay, so 3 pi over 4 and 7 pi over 4. For these values of x, our corresponding value of y, or the functional value, would be -2. We can actually eyeball it from the graph, right? Okay. Now, we want to see for which values of x will actually have a positive functional value. That means our corresponding value of y would be positive. Okay. So if you remember the basic property of a graph, let me redraw it. Excuse me. Anything below this line, y is negative, right? Anything above, we say y is positive. We want to find the values of x for which this is true. That means for which we'll have positive value of y, or the functional value, okay? Y is basically the function, right? F of x is y, we know that. So that's literally the function. Okay, so we just need to check these areas. Can you see that? Because only in these areas, our graph is above this line. And this is 0, 0. This is pi 0. This is 3 pi over 2, right? Am I doing it wrong? Let me see. Yeah, 3 pi over 2. Oops. 3 pi over 2, okay. Yeah, that's right. So that's 3 pi over 2, and that is, oh no, I did it wrong. So this is basically pi over 2, right? Yeah. So let me redo this. Okay, yeah. So this is pi over 2, 0. This is pi 0, and this is 3 pi over 2, 0. Okay. Now, we want to see the area or the region for x, or the values of x rather, for which this is true, right? So as you can see, in this region, our value of x starts from 0, ends at pi over 2, right? And for this particular region, let me use different color. For this particular region, you can see our x starts from pi and ends at 3 pi over 2. Can you see that? So finally, we'll say that, hey, our answer would be from 0 to pi over 2. We'll use the first parenthesis because at 0 and at pi over 2, the value is actually 0. We want only greater than 0, right? So that has to be, these two values has to be excluded. And we also have another interval from pi to 3 pi over 2, right? From pi to 3 pi over 2, yeah. So for these two intervals of x, we have positive values for y, and as we have two different intervals, we'll use this union sign, and that's your answer. Okay. Now, we'll take another example and we'll try to find different values from that. Okay. We'll try to see what happens if a function is, or rather expression is given. Okay. In the first example, for this one, Let's write this as example 1. This is when the graph is given, so we can eyeball it. We don't need any calculation for it. But let's say we have another example in our hands where instead of a graph, we are given a function, okay? X plus 3 and x plus 4, okay? And from this, we want to find different answers. Let's see what are those. First of all, we want to find the domain. And if you have seen my previous video, I did say whenever we have a fraction in our hand, we need to set that to 0, solve it for x, and apart from those values for which the denominator is 0, everything else is our domain, right? We'll just exclude the values of x, which is making this denominator 0. So if we set our denominator to 0, we solve it for x, we'll get x equals -4. So apart from -4, everything else will be our domain, right? So we'll say our domain is all the x such that where x is not -4. Without -4, apart from -4, everything else is domain. So that's how we can write. Or using the interval notation, we can write like this: from -infinity to -4, union from -4 to infinity. That means we are actually excluding this guy, -4, and apart from that, everything is our domain. Okay? Okay, now, the next question is whether the point 1, 3/4 is on the graph or is on the graph of this function. That means whether that's a point of this particular function. So as you know, as we know rather, the first value comes from x, second value comes from y. So what we can do, we can plug in x in place of the x's we have, and if we just get 3/4 in return, that means the point is actually on the graph. Otherwise, we'll say, no, this point is not on the graph, okay? Let's see what happens. So if we plug in, let me rewrite the function for you. F of x was x plus 3 over x plus 4. So f of 1, as you can see, the value of x is 1. So we'll replace all of the x's by 1. So 1 plus 3 and 1 plus 4 gives us 4/5, which is not at all this guy. So we'll say this is not 3/4. So 1, 3/4 is not, is not on the graph, on the graph of f, of this function, right? Because if I plug in 1, I get 4/5 instead. Okay. Now, next question. What's the functional value of x, or rather, what's f of x when x is 2? Let's see, by the way. Yeah, let's see. So we want to check what happens if we plug in 2 in place of our x, right? Let's see. So f of 2 would be 2 plus 3 and a 2 plus 4. I'm just replacing all of my x's by 2, right? Because I'm replacing this as by 2 or this by 2. So 5/6 is the value which we are looking for. And as we are getting 5/6 for 2, So this point will be on the graph of f, right? Because by plugging in 2, we have got 5/6. So this should be a point on the graph. Can you see that? For the same reason, this is not on f. This is actually on f, right? Because we are getting this value by plugging in the value in place of x. Okay, now for D, we want to find the value of x. That means it's actually the other way around, for which our functional value is 4. Okay, so that means we want to find the value of x, for which in return the corresponding value will be 4. So that means our function was x plus 3, x plus 4. This will give us a 4. We need to solve it for x, and this will give us our result. So by solving this, I can get a -13/3. If you just solve it, okay? If you by chance can't solve it, email me, okay? But I really hope you can actually solve it, because we have done this in Math 95 or 96. So you can actually solve it in terms of x by just cross multiplying this to there and isolating the x. Anyway, so for whenever x is -13/3, we'll actually get 4 as the functional value. Okay, so the value on the graph would be -13/3, and the corresponding value will be 4. This will be on the graph of f, graph of the function f. Okay. Finally, the last question is, what are the x-intercepts of this graph? What are the x-intercepts? So let me just quickly show you what is an intercept again. If your graph goes past this x-axis, it has to touch or actually go through the axis, right? It has to intersect at least one point on the x-axis if it actually goes past this. So this point is called x-intercept, where your curve intersects with the x-axis. Similarly, if your graph intersects at any point on the y-axis, then we say that this is your y-intercept. Okay, and a very clever way to calculate y-intercept and x-intercept is, as you can see, this is x-axis, and on this axis, on this line, y is always 0, right? So if you're trying to find x-intercept, if you just plug in y equals 0, that means if you just start your functional value 0 and solve it for x, you should get your x-intercept. Similarly, this is your y-axis, and on this line, x is always 0. So if you just start with x equals 0 and then solve it for f of x or y, you should get your y-intercept. Okay, so now for this particular problem, we are looking for the x-intercept when our function is x plus 3, x plus 4. Okay, we're looking for the x-intercept. That means we'll actually set this guy to 0, right? As I said, we need to set f of x or y, either one, this one or this one. We need to set this to 0 and solve it for x. So this guy is 0, x plus 3, x plus 4. If we solve it for x, we get x equals -3. So our x-intercept is, the point rather, is -3, 0. Because for -3, of course, our value, as we know, is 0. So this is the x-intercept. Okay. So a quick question for you guys. I'll ask this tomorrow. Find the y-intercept. Okay. Okay, so that's 2.2 for you. I'll just finish this here and I'll upload another video for 2.3. See you after a while. Bye-bye.